In this video, we're going to explore the number data type. We will check out the basic operations of the number data type, some notations of numbers, also some exercises, and at the end of the video, you will learn some special numbers that are distinguished in JavaScript. So the basic operations, addition, subtraction, multiplication, and division are the same as in most programming languages, actually. So 5 plus 2 is 7, 5 minus 2 is 3, 7 times 4 is 28. Now, when it comes to division, we have floating point division, which means that if you have 7 over 5, then the result is 1.4. But there is also this concept of whole division, which means that the result of a division is an integer. For example, 7 divided by 5 is 1, and then we denote the remainder. So in this case, the modulus operator, the percentage, denotes the remainder. And here we have 7 modulus 5 equals 2. This means that we perform the division, and whatever the remainder is returned by the modulus operator. Another frequent operation is the power operator. It's denoted by 2 asterisks, starting in ES 2016, by the way. So 5 asterisk asterisk 2 is 25, because it's 5 to the power of 2, which is 5 times 5. Now if you have 5 to the power of 3, the result is 5 times 5 times 5 equals 125. So far our task is straightforward. But then comes the tweak. In most programming languages, not only in JavaScript, if we try to add 0.1 and 0.2, now what happens in this case? The result, we would expect the result is 0.3, but no, in reality it's 0.3, a lot of zeros, and then a 4. This is due to floating point arithmetics, the way how our processor computes the results. Unfortunately, we have this loss of precision. And this is one of the most famous examples that highlights this loss of precision. And unfortunately, we have to live with it. I will soon show you how to deal with this loss of precision. But before that, let's explore another notation which illustrates how we can still represent numbers without this loss of precision. So there is a concept of normal values in mathematics where we have a number between 1 and 10 and an exponent which is a power of 10. So for example, if you write 3.1e minus 3, it's a notation for this normal value. It's nothing else but 3.1 multiplied by 10 to the power of minus 3. So just for some examples, 1e1 is 10 to the power of 1, which is 10. 1e2 is 10 to the power of 2, which is 100. In general, we have as many zeros in the after the 1 as the exponent. It also works with negative exponents, so 10 to the power of minus 1 is 0.1, 10 to the power of minus 2 is 0.01, and so on. Here you count the number of zeros before and after the decimal point, and it's minus 1 times the exponent. Getting back to the example, we could argue that we could have written 3.1 times 10 to the power of minus 3 because we know all the operations, right? But then, if we execute this, we get a different result because of floating point arithmetics. This is because if you write 3.1e minus 3, it's a notation for a given number. But if you write 3.1 times 10 to the power of minus 3, these are actual operations that are performed by JavaScript. And then we have the loss of precision due to floating point arithmetics. So be very careful what you write and how you denote numbers. I promised you some solutions to this problem, right? So let's dive into it. If you know the number of digits after the decimal point, you can fix these digits, and then you can just represent the whole number as integers. So for example, if you have dollars and cents, why not represent the whole value in just cents and then just perform operations on integers and not on floating point numbers? So for example, if you have 25 cents, you just write 25 and not 0.25. This way, if you add 10 cents and 20 cents, the result is going to be 30 cents. However, if you had dollars, you would have to add $0.1 and $0.2, and the result would be this loss of precision 0.3 or whatever plus the 4 at the end. So this is one of the solutions. If you know the number of digits, you don't have to do anything else but just represent them as integers. And then you have no problems with the loss of precision, at least as long as you use addition, subtraction, and multiplication. As soon as you use division, you will have the problems, but then you can use the second solution, which is truncation or rounding. Now, instead of truncation or rounding, I will show you a way to print the number in a specific way, so formatting, because you could use rounding or you could just use this fixed notation, which I'm going to show you. So imagine you have this 0.1.0.2. We already know that it's not going to be too safe to add these two numbers, but we could just wrap it inside number. So we have this number constructor and call the toFixed method of this number. And in this toFixed method, we can add the precision. This precision can be 1. In that case, the number of digits after the decimal point is going to be 1. So we have 0.3. If you want 2 digits, in that case, the parameter inside toFixed is going to be 2. And then we have the result 0.30. So this is how we can write digits to the output. Be aware that the result is not a number now, but a string. So if you want to change it to a number, you can do it. If you want to round it, truncate it, you can use another method. So everything, well, at least most of these operations are possible in JavaScript. Moving on to an exercise. In this exercise, you will use everything that you have learned, or at least most of these concepts with numbers. It's very simple. You have 3 expressions and you have 5 values. And you need to match the 3 expressions with 3 out of the 5 values. So you can verify that your solution is correct if you found the correct value. Let's see the first one. 5 to the power of 2 is 25. 25 plus 1 is 26. The catch is that the power operator binds stronger than the plus. So for this reason, we have 25 plus 1 equals 26. You got the first value selected. Let's see the second one. 11 times 11 is 121. Then you have minus minus 4. The 2 minuses cancel out. They become a plus. 121 plus 4 is 125. You select the last value. The C expression is going to be a bit harder because you have this 1e2. We know that it's 10 to the power of 2, which is 100. Then we have minus 11 times 8. 11 times 8 is 88. So we have 100 minus 88 so far. Be aware that multiplication and division bind stronger than the addition and subtraction. So this is why we have 12 so far, 100 minus 88. And then we need to compute another expression, which is 2 times 2 over 4. 2 times 2 is 4. 4 over 4 is 1. So we have 1 in the third part. Then we have 100 minus 88 minus 1, which is 11. Let's conclude this video with some special JavaScript values, or special JavaScript numbers to be exact. The result of a 0 over 0 division is a special number called NaN. Yes, it is a number, but its value denotes that it's not a number. Why do I say that it's a number? Because the type of NaN is a number. I know JavaScript is weird, but accept it, this is how JavaScript works. NaN denotes not a number, and its type is a number. So if you want to check whether your result is a number, don't check the type of the result, but you can use another method. So for example, I think it's called number.isNaN that you can use in here for this specific check, but let's not get ahead too much. You can get an NaN value, for example, by multiplying a string with an integer. This is a big difference with respect to Python, where if we had ES6 in practice multiplied by 2, we would just repeat the same string twice. But no, here we get an NaN because multiplying a string and an integer results in a NaN. Let's see another special JavaScript numeric value. This is going to be infinity. 1 over 0 is infinity. If you have infinity times infinity, it's also infinity. So in JavaScript, we don't have these aleph null and continuum mathematical notations where you have countable infinity and the uncountable infinity. No, here we just have infinity. By the way, -1/0 is minus infinity. And if you have a large enough number, it becomes infinity in JavaScript. I think it's 309. Let's try it out. So if we have 1e308, it means 10 to the power of 308. It still writes the value in the console. But if you have 1e309, then the result is gonna be infinity. Alright, that was it for the number data type. If you liked the video, subscribe to this channel and see you in the next video.